Okay, welcome to the Conservation and Biogeography Lab. We're doing a lot on PowerPoint today, and for this lab, each group of students should have several different maps. Alright, so they should be given a laminated map, a precipitation map, a temperature map, and then two predicted climate models maps that we'll use later. And then they should have a species map of the distribution patterns of 5 different species. So red brome, pika, desert tortoise, Joshua tree, and bristlecone pine. So they should have all of those. It would be helpful too if they had some wet erase markers that they could draw on these maps. So please make sure that they erase all the stuff that they drew on them when they're done with the lab. And let's see, what else do they need? And then there are packets for 6 conservation situations. So there's polar bears and disease, and there's several different ones. And there's a laminated sheet that says you've been given honeybees. And then it's got, if it does have some scientific articles that they were supposed to have, those are stacked behind them. So please have the students be careful with those and recognize that those are being used again and again. If we need to make new copies, by all means let me know, and I'll make some new copies of those. They're getting pretty tattered. There are only 6 scenarios, and I realize that some semesters we have 8 groups and some semesters we only have 6. So if we have 8 groups, just on part 3 of this activity, have the extra groups break up and disperse amongst the other groups because we only have time for 6 presentations. Alright? Okay, so this lab starts off part 1 looking at climate. So I'm going to turn this around. Okay. And so you're going to put this up. This is the first slide on the PowerPoint I will send you. And you're going to put this up. This is a map of California and Arizona. Okay, and it's got Mount Whitney on there, and Sacramento, and Phoenix, and some of the things they need for the questions. So part 1 of their student guide, they're going to answer questions 1 through 5. Okay, and you'll be walking around to help them. So the first question asks, why is Southern California warmer than Southern Washington State? Okay, and so on this map, they're looking, down here in California versus way up in Washington State. So they should be able to figure out that this is a latitude thing, all right? And I'll show you, we've got some slides that will help. So you're going to let them talk about it in their groups first and try to answer the questions, obviously, before you have a discussion. But when you do have a discussion, I've added some slides that will help you out. So the first question, that why is Southern California warmer than Southern Washington State, is a latitude issue. So if you use this slide, it shows the global mean temperatures by latitude of the globe. All right, and so obviously around the equator we have the warmest temperatures, and up at the poles we have the coolest temperatures. So as you move up the coast of North America, you're going to get cooler. So even though they're both along the coast, one is at a higher latitude. And then you might ask students why. Why is it warmer at the equator than at the poles? Now hopefully they can say that it has to do with the tilt of the Earth, right? And so at the equator we're getting more direct sunlight, and as you go to the poles you're getting more indirect sunlight. And I'll show you a better picture of that in a minute. Number 2 asks them, why is Oceanside, California so much greener than Phoenix, Arizona? So I'm going to go back to the map for a second. So I've labeled them both on here. So you've got Oceanside over here and you've got Phoenix right here. And so they are at the exact same latitude. So why is one a lot greener than the other? And so one of the things is we are close to the coast, but that's also because there's a mountain range that runs right in between them. Okay? And so what you're going to show them is this next slide, that's the rain shadow effect. All right, so if you have a mountain that's in the way as the wind pattern is flowing over the mountain, as it travels up the mountain you can see that the temperature is getting cooler as we go up. And so the water begins to precipitate. That's any water in the air that's been taken off the ocean is going to precipitate on this side of the mountain range. So on the other side of the mountain range you have very dry air. So this is Oceanside and this is Phoenix. Alright, so you get this drying out effect of the mountain range. So mountain ranges have a big effect on climate, on local climate. Okay, and then the next question asks them, why is Mount Whitney so much colder than Sacramento, even though Sacramento is farther to the north? Alright, so Mount Whitney is labeled with an A and Sacramento is labeled with a B. So you can see Mount Whitney is lower in latitude than Sacramento, so you would expect it to be warmer. However, this is the same issue as, you can use this same slide, that you've noticed, they should notice that as you go up in elevation, that your temperature cools down. So Mount Whitney obviously is a lot higher than Sacramento, California, and so you get cooler temperatures. Number 4 asks, why do we have seasons, right? Why do days get shorter in the wintertime? Why is December a summer month in Australia? This is an excellent question to make sure you spend a lot of time on, because this is one of the most common areas for misconceptions in students. And I can show you some of the most common misconceptions that students have. I'm going to move over to the board here for a second. All right. Okay, so one of the common misconceptions that students have, there's a couple of them. Okay, let me make sure that you can see this. Oops. All right, so one of them is the idea that if this is the sun, right, that somehow the Earth is getting farther away and then closer. And this comes from the fact that in textbooks, it's always drawn sort of, it's supposed to be 3D, but some students actually believe that it's an ellipse, right? So when the Earth is way out here, it's cold, and then when the Earth is right here, it's warm. Okay, so that's one of the less common ones, especially here at BYU, but it is one of the more common ones we see amongst younger students. So you want to make sure that that's not the case. The other common misconception, probably the most common misconception, is again having to do with distance. And that is, so let's say, it really is a circular orbit, but that the Earth, wow, that is not to scale, that the Earth is on a tilt, right? So here's the equator. So right here, this is closer to the sun than these guys over here. These guys are farther away, right? So this is farther, this is closer. And that's a common misconception too, is that this distance, okay, would make it somehow colder or warmer. And I love to throw at students too, well, let's say there was a mountain sticking off the Earth right there. Would that actually make it warmer because you're going up the mountain and you're getting closer to the sun? And usually they can say, well, of course not. That makes a negligible difference going up the mountain. And in fact, the air pressure is getting lower, and so there's less heat trapped in the air, so it's actually cooler. But going up the mountain shouldn't make a difference, right, in your closeness to the sun. And then I point out that it's the same thing here. This closer, farther, it's a negligible difference, okay? The orbit around the sun is effectively round, and this closer, farther does not make a difference. What it is direct and indirect sunlight, right? So I'm going to show you a PowerPoint picture that does a better job of illustrating it than I can. I'm going to flip back around here. Oops. Alright, so if you're looking at that, you can see these blue arrows represent packets of energy that are coming from the sun. And you can see that when the Earth is tilted, the bottom part of the picture, you're seeing that sunlight is hitting more directly. And so all of that energy is concentrated into a smaller area than that top arrow, where the same amount of energy is being spread out over a larger area. Okay, so it has to do with how much energy is hitting per area. And so with the tilt, and you can think of a flashlight, if you've shown a flashlight on the top of a basketball versus right at the middle of the basketball, the light's going to spread out and be dimmer. Okay, so less energy. Now it's not dimmer, the sun doesn't get dimmer, but it's less energy, okay? And so it's the tilt of the Earth, not the distance. And you want to make sure that students really understand that it's a tilt thing, not a distance thing. And I added another picture that I find sort of helpful. So it actually shows the tilt of the Earth, and you can see how, down here, this is a little bit weaker of the sunlight than right here in the middle. It's weaker up here too, and so you're going to get cooler temperatures down where it's weaker than right here in the middle where it's warm. All right, so number 5 asks them to just make a list of things that might affect climate. So they should have on their list things like mountain ranges, the season, what season we're in, the proximity to the ocean, latitude, altitude, things like that that would affect climate. And then it asks, do you think that these will affect the plants and animals that live there? Well, of course they will, right? Because every species has a different tolerance to heat or cold or lower or higher precipitations. And that's what we're going to deal with in procedure or in part 2. So you want to make sure that students get to that idea that these climatic changes are going to affect the species that will live there and how they will survive. Okay, so we're going to go on to part 2.